Alright, so today we are finishing up the experiment that we've been working on for our Monday and our Tuesday work, and the first thing I ask you to do is graph your data from your table from yesterday. So I'm going to put up some just like sample data to show what I would do if this is what my results sort of looked like from that. So let's say that at this two-notch part, and an important thing to notice even just when you approach any graph first is what are my axes. So we have the notches on the bottom, so you all figured out what your spring constants were for the second, fourth, sixth, and eighth notch. I left space for the 10th notch because some people might like to sort of use a linear sort of extrapolation to make a prediction for what that 10th notch spring constant would be. So let's say that my data looked like this. Let's say that at the second notch, I got 5 newtons per meter, and I'm picking even numbers or round numbers right now just as an example. My guess is that many of you found a lot of decimals in your answers, so it's totally fine if you really make like some predictions for where certain things would be. So if I found like 6.42 or something down here, it's certainly okay to make an estimation as to where that would be on this graph. We're sort of doing like some ballpark estimations here. But let's say for my data, I found some very even numbers just to make it easy for this demonstration. So let's say at the fourth notch, I found that it was 7 newtons per meter, and then at the sixth notch, maybe 9. At the eighth, we'll go 11. And this is what my data looks like. I would probably recommend using this like little line symbol over on the left side. You might not be able to see it in this video, but over on the left, it should give you options for those lines and how to write things. So I'm going to use that line function, and I'm just going to connect these dots that I have. And in fact, I'm going to extend this out so that it goes through all of my dots, all of my data points, and actually reaches this 10th notch, because the ultimate goal of today is to predict what that spring constant would be for that 10th notch. Now, some of your data points might be a little off this graph. Of course, in our experiments all year, we haven't found any data on a perfect line like this, so it's okay for you to use your judgment as to like making that line of best fit. We're not going to go through doing linear regressions by hand today. That's a whole another topic. But you can sort of ballpark what this line should look like, and then my prediction based on this line, it looks like it would be at 10 notches around 13 newtons per meter. And since I picked really even numbers, it would be okay for me to just say, okay, I think it's going to be 13 newtons per meter for that spring constant. Now the next thing that you're doing is explaining and giving your predictions. So for me, I might type, not for my correct answer, but I might type, I think it was going to be 13 newtons per meter because of when I did this linear extrapolation, that's where it looked like my data was heading. Or if the same trend continued out into the 10th notch, then I would predict that it would be 13 newtons per meter, or whatever my data tells me. Now, the last thing that you have to do today is use the data that you just sort of analyze and use to predict the 10th notch spring constant, is calculate some displacement for that 250 gram mass. And the way that you would do that is still using Hooke's law. So we have that spring force is equal to negative kx, and you can figure out, again, as you have a bunch of other times, what that spring force is. It's going to be the same as whatever your force of gravity or weight for that 250 gram mass is going to be. The spring constant, use your predicted spring constant. So for me, based on my data, it looked like it was going to be about 13 newtons per meter, but that is something from your prediction. And then once I know what what my spring force is, once I know what my predicted spring constant is, all I would have to do to make this prediction for a displacement is divide both sides by whatever's next to that. Let me get that in a different color. divide both sides by whatever is next to this x. So since I'm trying to solve for x, the displacement here, we would have to divide both sides of this equation by this k value, whatever our predicted spring constant is, and that would get us the displacement. It looks like you would get a negative displacement, assuming that your spring constant is positive because it's upward, and this spring constant has to be positive, and all that tells you is that the displacement should be down, which makes sense with all the other things that we were going over and what we were observing in our simulation. So keep those things in mind. If you need to, again, you can revisit your work from earlier in the week, but this really is sort of a culminating exercise where you are now making a prediction for that spring constant and finally using it to predict a displacement for our simulation for this mythical 10th spring.